Yes, good evening to everybody. I hope yesterday's construction you all completed. So now thinking that you are quite enough understanding the geometrical construction in the previous class, slowly I will move on to the another geometrical concept, that is lines and angles. Okay? It's a geometrical portion. Since you already started in unruled book, the geometrical construction, same book you continue for the next chapter, that is lines and angles. Lines and angles. So we'll define few basic concepts regarding the geometry. Then I will move on to what exactly the axioms states, what about the intersecting lines, what property it stands, every detail you will have. So make use of your unruled book, put one working column here, whenever the figure is there, get the figure and write up the definition with serial number here, question number 1 like this. Because it is unrolled book, you won't have margin, so better to have a margin here, okay now? So right from the basic concept in geometry, we started from the first point is point. How to define a point? So I will show the point like this. We define a point as a small dot made by a sharp pencil or sharp edge. There is no length and breadth of this, there is just a mark taken by the sharp pencil or sharp edge. So we define a point as a small dot by a sharp pencil on a plane. So symbolically we write with this box a dot or a point. Okay na? Next, so I will write here a small dot by a sharp pencil or edge is a point. It has no dimension. It is just a mark made by a sharp point. Okay. Next. Question or definition 2. Line. So we represent line like this. Symbolically we represent line. It is extended infinitely in both the direction. A set of points extended in both directions. In both directions is a line. So here a line has no fixed point. It is extended indefinitely in both the direction. If I take like this, further it will extend right side, it will extend left side, it is a line. So in geometrical way we define a line as a set of points extending in both the direction. It has no fixed point. Okay. Next. Line segment. We write line segment like this. It is a part of a line having two fixed points. So we can measure a line segment but we cannot measure a line. It is extending indefinitely in both the direction, whereas line segment has a fixed point and we can measure. It is a part of a line. A line segment is a part of a line, with two fixed points. With two fixed points. We define a line with respect to line segment. Line extended both the direction, no fixed point. Line segment is a part of a line having fixed point, and we cannot measure a line, we can measure a line segment. Is it clear? Can we say, yes, entirely line segment is different from a line. Line is just a set of points extended indefinitely in both the direction, whereas line segment is a part of a line with two fixed points. We cannot measure a line, we can measure a line segment. Clear? Next. Ray. So we symbolically represent ray like this. A ray has fixed point ray has one fixed point extending in only one direction. Only one direction. A jet of a plane, that is a path, it is posing a path of an arrow. So it is starting from fixed point, it is extending, then we call that as a ray. It has only one fixed point, whereas a line segment has two fixed points. Is it clear? Next, point number 4 or question number 5. Collinear points. Collinear points. Take the figure of a collinear points. These are all collinear points. Why they are collinear points? They are all lie on the same line. So therefore they are collinear points. Points which lie on a straight line are called collinear points. If not, they are non-collinear points. Points which are lie on same line are called collinear points. Non-collinear point, question number 6. Non-collinear points. Collinear means points which lie on the same straight line. Non-collinear means points which do not lie on the same straight line. Is it clear now? Are you able to see? Arya? Okay? Aryan, now it's okay? Non-collinear points. Points which are not lie on the same line. I'll give the figure for non-collinear points. Point A is here, point B is here, point C is here, like this. Then we say that they are non-collinear points. So take up the notes of this basic points in geometrical part. A small dot by a sharp pencil or edge is a point. A set of points extended in both directions is a line. Line segment is a part of a line with two fixed points. A ray has one fixed point extending in only one direction. Points which are lie on same line, same straight line, also you can write same straight line, or collinear points. Points which do not lie on the same straight line or non-collinear points. So putting the margin, writing point 1, point 2 along with the diagram, you have to write up the notes neatly. Okay na? Shall we move to the next points? You all taken? Definitions, I hope you all taken. Point number 6 or question number 6. Okay na? Next, an angle is an angle. Next heading is angle. Point number 7. Get the figure of an angle. Take the figure of an angle. Vertex. This common point is in vertex. Non-common lines, they are called arms, A-R-M-S, arms of an angle. Get the figure and note the label here. Arms, vertex, again arms. So below the figure you write. Below the figure, an angle is the union of two non-collinear rays. An angle is a union of two non-collinear rays. Below the figure you write with a common initial point, non-collinear rays with a common initial point. This is the common initial point. We call it as vertex, V-E-R-T-E-X, vertex of an angle, and these two are non-common arms. They are the non-collinear rays. They won't meet. They are different. Collinear, they are not collinear. Non-collinear means they are not common, uncommon. The uncommon rays we consider as arms of an angle. So get the definition along with the figure with the heading angle. Next heading, point number 8, adjacent angles. Adjacent angles. Get the figure for adjacent angles. It has one common arm and other two non-common arms like this. With a common vertex these are adjacent angles. So we define adjacent angles. Here it has an common initial point with non-common rays and a common ray in between. So we call this type of angle as adjacent angles. Adjacent angles having the common vertex, common arm and non-common arms on either side of the common arm. Then we say that these are adjacent angles. Clear? Take the figure under the heading, then write the definition. Two angles are called adjacent angles if they have common vertex. Here the common vertex is O with the common vertex. Okay, and also I continue. They have a common vertex and common arm. Which is the common arm here? OQ is the common arm, and OP and OR are non-common arms. So if they have common vertex, continue, they have common arm and two uncommon arms on either side. Uncommon arm on either side of a common arm. Then only we consider they are adjacent angles. Which are adjacent angles? Angle POQ and angle ROQ are adjacent angles. So this geometry part full of definition, full of axioms and properties. Okay, we have to practice as it is. All this will be making use while solving, while finding, while analyzing the problem. So beginning I am giving this as a note. You have to get the note along with the figure with the definitions properly. Okay. Two angles are called adjacent angles if they have common vertex. Here common vertex is O. Okay. They have common arm. OQ is the common arm. And also two uncommon arms. That is OP and OR are two uncommon arms. Okay, they are on the either side of the common arm. Common arm either side, these two are uncommon arms. So we read out these adjacent angles as POQ, ROQ. We can also read out as QOP, QOR. Okay, QOP, QOR. Always we mention these adjacent angles with three letters only. We cannot write angle O, angle O. It's not a complete angle. Whenever we mention the adjacent angles, we use three letters P, O, Q, where the middle letter represents this angle. R, O, Q, this portion. Okay? So such type of angles we call it as adjacent angles. Pakka adjacent angles, neighboring angles. Okay? So angle with common arm and two non-common arm with a common vertex, they are said to be adjacent angles. So with the definition, with the figure, if you have the confusion together, you can take the figure in the right side of your working column, make a margin and show your notes in a beautiful way. Okay? Okay? Next. Shall I move on to the next one? I will write here. Linear pair angles. Take the heading next. Point number 9. Linear pair angles. So linear pair angles, they are adjacent angles, but their non-common arms are in opposite ray. Here they are not in opposite, they are either side of the common arm, whereas linear pair means the non-common arms are in the as an opposite rays it lie. So then we say such type of angles as linear pair angles. I'll get the figure here, how the linear pair angles looks. With a common initial point, if I do like this is a common arm OA and B and OB and OC are non-common arms. These two non-common arms are as opposite rays. Then we say these two angles as linear pair angles. So get the figure, below the figure you write below that you write two adjacent angles form linear pair angles, linear pair angles if their non-common arms are opposite rays. Here the non-common arms are OB and OC. They are directly opposite, OA, OB, OC. Okay. Now we consider angle AOB and angle AOC form linear pair angles. So here we consider an adjacent angle has a common vertex. Non-common arms are either side of the common arm. If the non-common arms are either side of the common arm having their opposite way, then such type of adjacent angles are called linear pair angles. The sum of the linear pair angles is always supplementary. Supplementary means 180 degree. So we have axiom based on linear pair axiom. So that we do later. We are doing now definitions. We follow now. So after linear pair angles, we move on to the next is vertically opposite angles. Vertically opposite angles. That is, when two lines are intersect. Based on this, in the construction chapter, you have constructed the bisectors. Here again I am showing AB and CD are intersecting at a point O. Then the pair of angles, opposite angles, are called vertically opposite angles. Get the figure? When two lines intersect, when two lines intersects at a point, then the angles so formed when two lines intersect, then the angles so formed are called vertically opposite angles. Vertically opposite angles. They are equal. Which are vertically opposite angles here? Angle AOD. Angle AOD equals angle BOC. Now another pair, angle AOC equals angle BOD. These are all pair of vertically opposite angles. When do we get these vertically opposite angles? When two lines intersect each other. When a ray stand on the line, then they form a linear pair angles. When two lines intersect each other, then we get vertically opposite angles. You have to repeat the definitions confirm the definitions, because whenever the figure is given you have to identify what type of angle is that, what is the property, how it differs from other angles. All those you have to keep in mind to solve or to prove. So geometry part is full of definition, full of proof. Very easy, but unless you understand the basic concept. So that is the reason I am giving the notes, not only giving the explanation. With the figure, with the notes I am giving, you have to repeat the explanation along with the figure. Okay? Figure is must, definition is very important. So now we got vertically opposite angles. How vertically opposite angles form? When two lines intersect each other, then the pair of angles so formed, they are equal. They are called vertically opposite angles. Okay, na? It's clear to everybody? So just go through the definitions what and I given. So that is useful while answering. Okay. Excuse me. Now we'll move on to the next concept. It is axiom. So we'll go with the definition of an axiom. Here an axiom, A-X-I-O-M. Axiom is a proven statement without proof, whereas theorem is a statement with proof. Some statements will make use to prove some other statements. When we prove it, it is a theorem. When it is a true statement without proof is a axiom. Like that, we have now axiom 6.1, axiom 6.2. Always you have a pair of axiom, one statement, its converse is another statement. That means if you study well, you will score marks. If you are scored marks means you have studied well. That is a converse statement, right? If you feel hungry, you will eat more. If you are eating more, that means you are feeling hungry. That is the converse statement in mathematics, that is in geometry. So now take the heading axiom 6.1. Axiom 6.1. So we define axiom as a true statement. An axiom is a true statement without proof. If you want, you can write in the bracket, an axiom is a true statement without proof. So we use these statement axioms to prove some other statement, then we call that as a theorem. Okay, na? So now we define an axiom 6.1. According to that, if a ray stands on a straight line, the sum of the adjacent angles so formed is 180 degree. Conversely, if the sum of the adjacent angles is 180 degree, then their non-common arms form a straight line. So how I said that as an example, if it is right, you are doing this. If you are doing this means it must be right. Like that, here axiom 6.1, below that again take a small figure representing this statement. So according to this statement, see the explanation how I am going to do. A ray OC. Why it is ray? Why OC is called a ray? Don't you know the answer? Why ray OC is called a ray? I have given the definition of a ray before. Yes, it has a initial point, only one point. Very good. Since it has only one point, fixed point, OC is a ray, AB is a line. Okay? When a ray stands on a line, the sum of two adjacent angles is 180 degree. Okay? Conversely, if the sum of the adjacent angle is 180 degree, then the non-common arms, which are the non-common arms here? OA and OB. They are the non-common arms, form a straight line. They are on the opposite rays. That is, if a ray stands, their angles is 180 degree. If their angles are 180 degree, then it must be a linear pair angles. So that is regarding axiom 6.1. So here, below the axiom, get the figure. Below the figure, write the statement of axiom 6.1. Right? If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. Here the adjacent angles so formed are angle AOC and angle BOC. That is angle AOC plus angle BOC equals 180 degree. Get the statement neatly. So here you will get a question, state axiom 6.1. In such case you have to get the figure and you have to write up the definition, like if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. So I have shown which are those adjacent angles. They are AOC and angle BOC, where these two angles are linear pair angles. The linear pair angles forms when a ray stands on a straight line. Then they form a linear pair angles. Now axiom 6.2 is its converse. Axiom 6.2. Axiom 6.2, right below that, if the sum of adjacent angles, if the sum of adjacent angles is 180 degree, then the non-common arms of the angles form a line. It must be a straight line. When it is straight line and if a ray stands on it, then the sum of two angles is 180 degree. Conversely, if the sum of two adjacent angles is 180 degree, then the non-common arms form a line. Then only we consider their sum is 180 degree. Is clear? If you want to show they are pair of linear angles, that is linear pair angles, if the sum is 180 degree. Conversely, if the sum of two adjacent angle is 180 degree, they form the linear pair angles. This is how we define axiom 6.1 and axiom 6.2. Go through it once again before I move into the next concept. Okay, after that you write the above two axioms are called linear pair axioms. So in the question, in the examination, if you have state linear pair axioms, then you have to write the figure axiom 6.1. If a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degree. Axiom 6.2. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a straight line. They are non-common arms. OA and OB are non-common arms, where OC is a common arm. So we call together as a linear pair axioms. A linear pair angle axiom means it states that if it is 180 degree, they are linear pair. If they are linear pair, their sum must be 180 degree. So based on this, we can find out unknown angles, unknown values. we can identify which are the pair of angles, what is the relation, everything we can go with the further application part. Okay, you need these definitions perfectly. Without definitions will be difficult to answer. So recall the definitions again and again, read out loudly, try to explain to everybody, try to explain among yourself, so then only it will be a perfect. Geometry, no other calculation, no addition, no subtraction, no formula, only is based on the properties, laws, principles like that. Okay, so repeat the definitions again and again to get the confirmation. Now is it clear? I will move on to the next concept. Everybody clear with these definitions? You must read it again and again. Okay, next. So now we do, based on this problem, few questions. Shall I rub this question? Take the question now. All the definitions, axioms, everything is over. Next we have the theorem. Before the theorem, I go with simple problems. Okay. Question number 1. If OA and OB are two opposite rays, find y if x equals 75 degree. So opposite rays, that means it is understood they form linear pair angles. So get the figure in the right side of your page as a working column. Get the figure like this. OA and OB are two opposite rays. If x equals 75 degree, find the value of y. This is the question. So now we use linear pair angle concept. What is the linear pair angles? Sum of the two angles is 180 degree. Since they form the linear form, they are the opposite rays. When they are opposite rays, that means it is understood that they form the linear pair angles. So here you write, since OA and OB are two opposite rays, therefore angle AOC plus angle BOC equals 180 degree. In the bracket you write linear pair angles. Now AOC is x degree, BOC is y equals 180 degree. Where y you have to find out, x is 75 degree plus y equals 180 degree. Therefore y equals, get the answer as 105 degree. Is it clear? Making use of linear pair concept, here we calculated the unknown angle. It is represented by some other letter. Instead of mentioning the angles, they are represented by letter x and y. So the measure of y equals 105 degree. Very good. Next. Question number 2. If OA and if angle AOC and angle BOC form a linear pair, find the value of x. Find the value of x. Here is the figure. It is given figure. Shall I write here? Are you able to see? In the working column. It is given 4x and 2x. So now, already given in the question, AOC and BOC form a linear pair. Okay. Angle AOC plus angle BOC equals 180 degree bracket linear pair angles. Linear pair angles. Okay, now substitute the linear pair angle what they mentioned. 4x degree plus 2x degree equals 180 degree. 6x degree equals 180 degree. X equals 30 degree. This is how we can find out the value of this. Suppose in the question if they mention find each measure of the angle, means 4 into 30, 2 into 30 you have to mention. Since they are asking find the value of x, we found out the value of x. Is it clear? Easy geometry? Geometry is easy? Okay. Another question. Okay, shall I move on to the next question? It is given in figure, question number 3. In figure, can you see now? In figure, angle POR and angle QOR form a linear pair. Whenever they mention linear pair, it is understood sum is 180 degree. If A minus B equals 80 degree, find A and B. This is not in your textbook as an application question. Very important question. So we'll have the figure for this. See the figure. POR, QOR, this is A, this is B. Don't write anything, just see Punya present here today? Today's class Punya is here. Sonika, Shriya, Shravya, Raghavi, Aishani, Kevin, Lohit K, Madhumita, Dhruti, yes, Dhruti, Maulya TR, Maulya TR, Maulya from Jesus, Punya, Aditya, okay, Aditya present, Aditi Shetty, Aditi Shetty present, Nishant, Vismaya, Yashas, Shrikant, Bhuvan, Prajwal, Hansini, Kusum, Kusuma, okay, now we'll move on to this question. Okay, thank you very much. Here they have given a minus, don't write anything, just see the board. A minus b equals 80 degree. There is no x value, no value here. Okay. So now we should make use of the relation. The sum of the linear pair is 180 degree. So we write here a plus b equals 180 degree. Don't write anything. Okay, here write the reason, linear pairs. A minus b equals 80 degree, it is given. Okay, so now plus b minus b cancel, 2a equals 260, a equals 130 degree. I just added the two conditions. One condition is given in the question. Another condition is given in the statement that they form the linear pair. Using those two links, we got the measure of A. Therefore, B equals 180 degree minus A, 180 degree minus 130 degree, it is 50 degree. This is how we can find out the unknown values. One with the relation, the sum of the two angles form 180 degree. Another with the relation given in the question itself. Is it clear? Very good. Next question. In figure, question number 4. Question number 4. In figure, OA, OB are opposite rays and angle AOC plus BOD equals 90 degree. Find angle COD. Find angle COD. Okay, get the figure. Get the figure? Here they are all adjacent angles. The sum of the linear pair angles is 180 degree. So adding all the angles is 180 degree. But adding these two angles, it is 90 degree is given. We have to find out the measure of angle COD. This is another application of linear pair axiom. So take the figure. Below the figure you write, since OA and OB are opposite rays, therefore angle AOC plus angle COD plus angle BOD equals 180 degree linear pair angles. That is, when the non-common arms form an opposite rays, then the adjacent angles together linear pair. When they are linear pair, their sum is always supplementary, that is 180 degree. So now we know sum of AOC plus BOD is 90 degree, plus leaving those two, this is the left angle, equals 180 degree. Therefore, angle COD equals 90 degree. Okay? The extreme and sum angles is together 180 degree is given in the question. Since they are opposite rays, the total angles together we call it as linear pair angles. Sum of the linear pair angles is 180 degree. So substituting AOC plus BOD as 90, 180 minus this 90, you will get the measure of angle COD, that is also 90 degree. Is it clear? So see how we are applying the linear pair concept to find out the measure of the different angles. This is the application. Okay. Okay, we'll take last question, one more question. This is also regarding linear pair angles. Then I will continue in the next class. Okay, last question. In figure, question number 5. In figure, angle PQR equals angle PRQ. Then prove that angle PQS equals angle PRT. Get the figure? Get the figure in the right side of your page as a column here. Obtain the figure. PQR equals PRQ. You have to prove sum of these two angles equal. Get the figure? Over? PQS, PRT. Right. So here S, Q, R, T, they are on the same straight line. So we consider these two angles as linear pair, these two angles as linear pair. That is PQ stands on ST. Therefore, angle PQS plus angle PQR equals 180 degree. Linear pair angles. Take it as result 1. Next, PR stands on ST. PR stands on ST. Therefore, angle PRT plus angle PRQ equals 180 degree. Linear pair angles, equation 2. Sum of these two 180, sum of these two 180, but these are equal, so this is also equal, we have to prove. Okay, so now in equation 1 and equation 2 you have RHS equal, therefore you write from the result 1 and 2 we get angle PQS plus angle PQR equals angle PRT plus angle PRQ. But PQR equals PRQ is given, therefore angle PQS equals angle PRT. Bracket you write since angle PQR equals PRQ. By using number again I will show you. This is 1, 2, 3, 4. 1 plus 2 180, 3 plus 4 180. Therefore 1 plus 2 equals 3 plus 4. But in the question it is given 1 equals 3. So cancelling from both the side you will get 2 equals 4. Instead of number we are using the letters. Okay. So this is the questions based on linear pair angles. Tomorrow in the beginning I will prove the theorem 6.1. That is when two lines intersect, the vertically angles so formed are equal. Very, very important. So please be attentive for the live classes as well as the recorded. You have to repeatedly practice. If they are not regular to the classes, I am going to take off from the group. So please inform to your friends. I am very strict with this. You have to attend both the live classes as well as the recorded also you have to do. Okay? Inform to your friends about this. If I get any information that you are not regular to this, I will take out from the group. Please adjust with your friends. Thank you. We'll see in the next class. Okay now?